Hey guys, it's Sadiya here at the Math Center. I'm going to be talking a little bit about limits. So basically, a limit is some value of y that a function approaches at some x value. So the notation we use to describe this is we write the limit of some function f of x as x approaches some number, we can call it a, that equals some y value, let's call it L. So what if you have a function f of x equals x squared minus 1 divided by x minus 1, and you're asked to evaluate this function at x equals 1. What would that be? So f of 1 equals 1 squared minus 1 divided by 1 minus 1. That equals 0 divided by 0. And anything being divided by 0 is undefined. So we say that at x equals 1, our function is undefined. And even though our function is undefined, we can still use limits to describe how our function is behaving at values around x equals 1. So the limit as x approaches 1 of our function x squared minus 1 over x minus 1. In this video we're just gonna show the graphical way of dealing with limits. So the graph of this function looks something like this. And at x equals 1, it's undefined, so there's a hole here. So taking the limit of this function, we pretty much just see what value of y it's approaching from the left side. So if we look on the left side of the graph, we see that as we get closer and closer to x equals 1, it's about 2. So this is a 2 right here. 1, 1, 2. So at some number a little tiny bit smaller than 1, it's about equal to 2. And from the right side of the graph, as it approaches 1, some number a little tiny bit bigger than 1 is about equal to 2. So we can say that the limit of our function as x approaches 1 is equal to 2. So now let's look at another function. F of x equals 2x for x greater than 1 and 2x minus 1 for x less than or equal to 1. So let's just start by graphing this to see what's going on. So for f of x equals 2x for x greater than 1, we have, let's go up to over 1, and I'm going to use an open circle to indicate that it cannot be equal to 1. Up to, from this, so that's 2x, and for 2x minus 1, start at negative 1, go up to over 1, and I'm going to use a closed circle to to indicate that it can be equal to 1. So this is a graph of our function, and we see that from the left side it's approaching, at x equals 1 it's approaching y equals 1, and from the right side as it's approaching x, it's approaching x equals 1, it's approaching y equals 2. So since it's approaching two different values from the left and the right side, we say the limit as x approaches 1 of our function, we can say it does not exist since it's approaching two different values. We can't say which one. But we could further state the one-sided limits. So the limit as x approaches 1 from the left side, we use a little minus sign to indicate that it's coming from the left. The limit of that is 1, and the limit as x approaches 1 from the right side, we use the plus symbol of f of x. That limit equals, you see it's 2. And so the limit of the left side exists and the limit of the right side exists. However, the overall limit does not exist.